Hi, I'm Judy Cole, the Executive Vice President and CEO of the MIT Alumni Association, and I'm delighted to welcome you to this web production of the MIT Alumni Association.
Hello, everybody. Welcome to the MIT Faculty Forum Online Alumni Edition. I'm Wade Roush. I'm an MIT PhD from the class of 1994, program in Science, Technology, and Society. I'm the host and producer of a podcast called Soonish, and I am your moderator today. It is a real pleasure to be here. This is the first time that we've done the Faculty Forum Online Alumni Edition of a live studio audience. In a sense, they aren't here in the same room with me, but they are in a nearby room. And so for the first time ever, we've got a combined live audience here in the facility and an online audience, and we'll be taking questions from all of those folks as the chat goes on. So today, 3 MIT alums who will share some of their current research in robotics and automation and information technology, and how those 3 areas will transform the workplace moving forward. So we'll be talking about the changing nature of jobs and work in the 21st century, and the ways our economy and our job force are becoming more robust or productive thanks to technology. We may also get a chance to unpack or maybe even dispel some of the myths about the impacts that automation and robotics are having in various professions. We have people tuning in from near and far today. So as I said, we've got a live studio audience here in Concord, Massachusetts. And we'll be continuing the conversation with them after the 45 minutes are up. But we'll be taking audiences, and online we ask that you send in your questions using the little Google form next to this live stream. Now let's start by hearing a brief overview from each panelist. I'd like to basically ask the panelists to catch us up on what they've been doing in their careers since they left MIT. I'd like them to talk a little bit about their current research interests and their projects as related to automation, IT, and robotics. And then we'll have a free-flowing discussion. And as I said, that's from our 2. So we've got with us Varian at Google and an emeritus professor at the University of California. Also joining us, Lynn Wu, O2, and a couple of other degrees. I'll let her explain all of her different MIT accomplishments, but she's an assistant professor at the Wharton School. And finally, we've got Mike Gennert, or Gennert, I'm really sorry if I'm mispronouncing, apologies in advance, class of 1980, who is a professor at the Worcester Polytechnic Institute. So why don't we go in that order? Hal, could I ask you first to start by catching us up on what you've been doing since you left MIT, and what do you do now? What is your job about at Google?
Sure, happy to describe that. So I graduated in '69, as you heard. I went to graduate school at Berkeley, got my PhD in '73. And then I missed MIT so much, I went back and became an assistant professor there at MIT in course 14. In '77, I taught at, moved to University of Michigan and taught there for about 15 years. And then in '95, I came back to Berkeley to set up a new school called the School of Information that deals with exactly the kind of issues you were describing. So after 7 years of being dean, I got time off for good behavior. And I ran into Eric Schmidt, who said, I just joined this cute little company down in the South Bay called Google. Why don't you come and give us a hand? So I went there in May of 2002 and had so much fun, I stuck around. So I've been at Google for about 15 years now.
Hal, what kinds of roles do you play at Google? I know that you're called on to do all sorts of different things, from econometrics to finance and strategy advice. But do you basically help people at Google think through how the software they're creating and the search and other capabilities that Google is developing will change the way we work?
Well, when I first went to Google and I asked Eric what he wanted me to work on, he said, take a look at this ad auction. I think it might make us a little money. So I looked at the ad auction, and indeed it did end up making a little money, as it turned out. So that was the AdWords auction. Then we had the AdSense auction, the DoubleClick auction, Spectrum auctions, patent auctions. The IPO was an auction. So I did quite a bit of work in what we call market design, auction design, mechanism design, and so on. After that, did a lot of work of setting up the sort of statistical and analytic groups at Google that use the data that we gather to understand advertiser behavior, publisher behavior, user behavior, and so on. And in the last few years, I've been spending a lot of time working on policy issues like the items we're going to discuss today.
Terrific. Okay, let's continue with the introductions. Lynn Wu from the Wharton School. Could you tell us what you've been up to?
Hi, sorry, I'm at a hotel, so there's a maid just coming in. I graduated from 2002, and I was course 6 back in the day. I also I did a little bit of course 15, and then I went to Silicon Valley, worked for a couple of years, and decided that I should do a PhD instead. Gave up on some stock option here and there. Probably regretted it, but you know, such is life. I did a PhD in course 15 after I came back for MIT, during which, you know, I also got an MIng in computer science. So I spent about total maybe 11 years at MIT in education, and then after MIT, I went to Wharton School as assistant professor. I have been there for 5 years now. My research interest since then has been really about how big data has affected firms' productivity and what kind of jobs it has been affected. And the reason I'm choosing big data is because lots of advances in information technology and AI has been the availability of all sorts of fine-grained detailed data that we weren't able to capture before. And how firm leverages this technology, including artificial intelligence, may play a big role on how nature of jobs have changed, and also type of innovation firms has been producing over the last couple of years. So, for example, recently, and to understand that, it's important to see, what type of jobs and also what type of innovation firms have changed, and that's largely related to type of data that's been produced. For example, my recent work have shown that big data technologies, or big data having available access to lots of fine-grained data, can really help firms create refinement, recombination type of innovation. But to create a really brand new innovation that we have never seen before, and it's still, big data doesn't really help. There's still lots of creativity is involved with human gut instinct that actually still play a really important role in creating truly novel innovation that has not seen before.
Just quickly, Lynn, could I ask you whether you also study the impact of IT in workplaces? And basically, I think there's a little bit of a...
Uh-oh, I think I'm... Can you repeat that? I'm hearing choppy voices.
Which, is that the kind of thing that you ever?
So you're asking how? Can you repeat that question? Knowledge workers.
Yeah, small audio issues here, but basically the question in brief was: do you ever look at questions about IT productivity organizations, and yeah, do you have your own view on the productivity paradox, which is that they seem to be seeing investments?
Oh, I'm sorry. You're saying, am I seeing a new form of IT productivity paradox? Because I'm sorry, I'm trying to, get your question through choppy audio.
Yeah, I'm sorry, Lynn. So at this point, we'll come back to that question, but
Okay.
I'd like to go on, I guess, and introduce Mike. So back to this productivity question, I promise. Okay. Mike from Worcester.
Hi there,
and
Wade.
can say a little bit about what you're up to. Yeah, we'd love to hear what you've been up to since you left MIT.
Sure. So let me bring up a little PowerPoint here. All right. Okay, can you see that? Good.
Yes.
All right, so I went to MIT for a couple of stints. I was in course 6.1A and 6.3 and a master's degree, all of that in 1980. And then I went to GE in Pittsfield as a co-op student, went back to MIT, finished up, went to Power Technology Corporation in Utica, New York, did work on mostly military image analysis and processing. Spent a couple of years there, and everyone above me in the company had a PhD, so I thought, how hard can that be? So I went back to MIT for my doctorate. It was hard. And I worked in the AI lab and did work in vision mostly. Came to WPI in 1987, so I've been here 30 years with a stint as the department head in computer science, and I'm the director of the robotics engineering program, which is the first one of its kind in the country. So about 12 years ago, robotics was, if you saw a robot, there's probably this, a Roomba. Pretty clever device, fairly simple, cleans our rugs. But today you might encounter these robots. We have robots for surgery, for telepresence, underwater to clean gutters, deliver packages. There are human augmentation robots, robots in warehouses, and robots on Mars. So quite a change in the past dozen years or so. All right. About 10 years ago, there was this article in Scientific American by Bill Gates projecting the dawn of the age of the robots, that there would be a robot in every home. Well, that's almost coming to pass. So let's see what you need to make that happen. One big thing is education. We noticed there was this big gap in education between what goes on in the big research universities like MIT, Carnegie Mellon, Stanford, Berkeley, UPenn. And that was really cutting edge robotics research. And then robotics elsewhere was at the technology level, associate degrees typically. But who's educating robotics engineers? It really needs a whole new kind of way of thinking about technology. It's not just computing, it's not just mechanical, it's really a blend. And so we figured we'd make a program that would do that. And one of our slogans is making useful robots and making robots useful. So education in robotics includes computing, electrical engineering, and mechanical, those three things combined. Our students make these really cool projects, robots that will climb roofs, that can work with autistic children, robotic wheelchairs, kayaks, Mars explorers, you name it. We've got all kinds of robotic stuff going on here on campus. It's actually pretty cool stuff, and our kids work really hard on these projects. Our research involves humanoids and sensing, manipulation, human-robot interaction, medical applications, manufacturing, assistive robotics, navigation, mapping, soft robotics, a whole range of robotic research projects here. I'm the director of our humanoid robotics lab. We took part in the DARPA Robotics Challenge as part of our team and our robot, the Atlas robot. And so we work on problems of manipulation and walking, planning, and then combining perception and action. And right now we are competing in the NASA Space Robotics Challenge. That's a follow-on to the DARPA Robotics Challenge. And we're also involved in robotics for manufacturing. We're one of the universities in the Carnegie Mellon-led Advanced Robotics Manufacturing Institute, which is especially relevant for this discussion. Okay, so that's my little background.
That's fantastic, Mike. Thank you so much. That was perfect.
Thanks, Wade.
So your audio was a little bit spotty at the beginning of your talk, so the audience may have missed part of that, but then it became much better. So we're doing fine right now.
Okay.
And I think what I'd like to do is just a single question to the entire panel. And if you can hear me and if you are connected into the conversation, then feel free to jump in on this. But Mike, I'd especially like to hear from you how you cope with questions from lay people, from people in other disciplines at Worcester Polytech, or from regular folks when they say, "Gee, you know, I've heard that robots are putting people out of work." Is there a justified or perhaps unjustified level of concern about the impact of automation on employment in this country? How do you answer that question?
That's a great question, and I do hear it a fair amount. I usually just start by smiling at them and saying, "Don't worry." Now, in the long term, robotics is very disruptive, and it will change the entire nature of work. In the near term, it'll be slower, but it will happen. So the good news here is that most of the jobs that are being taken away by robots today are not really very interesting jobs. So for example, Amazon has an entire fleet of robots in their order fulfillment centers, their big warehouses. And in the old days, the way you filled an order was you had to print out what was needed for that order, hand to a person. That person walks around the entire warehouse, picking stuff out of the shelves, and they have to walk fast or run to meet their quota. Now you have the robots running around, unquote, and they bring the stuff to the human who picks it up and puts it into a box. So the drudgery of running through a warehouse has been taken away by these robots, but you need fewer people than you would have without the robots. On the other hand, the company's grown so fast, they're hiring more people to do the putting stuff into boxes. So it's this collaboration of people and robots that we're seeing today that's working out very well. And I think we'll see more of that because the robots aren't yet entirely able to do everything you'd want them to do.
Okay, that's a great way to start. So, Lynn, are you receiving me okay right now?
Yes, I do. I can hear you fine.
Great. Well, so I had asked you before whether you ever get a chance to look at the productivity impact of information technology engines. So this is a different spin on the robotics question, but it's since we're talking about AI and automation and IT in general. Do you have a response to people when they ask, "Boy, it seems like IT is just putting more people out of work. It's not necessarily helping us get richer. It's causing unemployment." So what's your response to that?
Well, I think it's both are somewhat true. That some jobs are being displaced, especially the one that computer and information technologies are really great at producing than humans can. Like for example, as you know, Michael just gave you an example of that in Amazon operations. But there's some other type of there's also some other type of work that's been created because of technology. So for example, to really a whole class of data science job is being created. Like we see we see a really huge growth in number of firms, also number of people looking for anyone, not just people with PhDs, but anyone who can analyze the tremendous amount of data that we're accumulating through social media, through mobile, through robotics, through any kind of sensors and through Internet of Things, and to really make sense of these data, that firms are creating a new set of jobs. And we're not talking these jobs are not necessarily has to be PhD level, and undergraduate levels, and maybe even special training after high school to really understand this data may be sufficient. And we definitely seen a growth of that. We actually found that the data scientists who do really well in firms are not necessarily the computer scientists, but the people who has a lot of in-depth knowledge about the organization, and coupled with statistical learnings, coupled with regression analysis and also data mining techniques. And they're not necessarily the person who run those algorithms, but they can look at those results and then understand what's going on within the organization, and then they do really well. So you're absolutely right. Information technology has displaced some jobs that technology has been great at replacing, but at the same time, they're opening up a new class of jobs, and it's actually this change, I believe, that's really this transition has been really difficult, especially for potentially older worker not need to be retrained. But in the future, I think I do share Michael's view. In the long run, it could be disruptive, but in short run, you know, it's still okay. It's still okay. But, you know, maybe one day robotics are so good and data scientists are displaced too. So I don't know, maybe Michael can get into that.
Right. Hal, you're part of Google, and Google's part of Alphabet, and Alphabet has all sorts of activities, including research on self-driving cars. It's one of the major centers for research in that area. So there are folks at Google who have to be thinking about what the long-term impact of automation and robotics is going to be on jobs and employment. But I wanted to ask you whether you have any way of measuring the impact of Google and cloud-based services on the economy over the last 15 to 20 years. So do we have more? We probably have fewer librarians than we used to, but we may have more of other kinds of jobs, right?
Yeah, it's hard to say. If you go back and look at the 1950 Survey of Occupations from the Bureau of Labor Statistics, there's actually only one job that's been eliminated by automation since 1950, at least in that list. And that is elevator operator. Now, if you're old enough, you may remember there were humans that operated elevators, but of course that job has been automated away. However, many of the tasks that elevator operators did, namely gave people directions, notified them of sale items, played a role in security, et cetera, those have been taken over by other occupations. So to think about this issue, you should start with the idea of tasks, and then it's bundles of tasks that make up jobs, and then you can look at what kind of tasks can be automated and what kind of tasks will be difficult to automate. There's a website that the Bureau of Labor Statistics splits up called ONET, and they list the tasks associated with jobs. So it's kind of fun to go there and look at it and see how those tasks line up with what you do. By the way, the 10 largest occupations in the US are retail salesperson, cashier, food preparation and serving, general office clerk, registered nurse, customer service representative, waiter and waitress, laborer, secretary and administrative assistant, and janitor. And those 10 jobs, just those jobs, account for 21% of total employment. And of those jobs, the only one that makes more than the median income is registered nurse. So it gives you a perspective. You go look at those job categories and you can say, I think, gee, it looks like there's going to be more automation in food preparation because we now have robots that can flip hamburgers and make pizzas and all these kinds of things. There'll probably be some more automation in the cashier area and so on. But I think overall, the right model is to think of tasks and the kind of human augmented robotics, or robotic augmented humans would be the better term, that will be the norm as we move forward.
Right. Thank you. Well, a lot of the occupational categories that you just listed, Hal, strike me as jobs that are going to be difficult to automate. Not all of them. Food prep maybe will be easier, but some of them are jobs that will be perhaps never automated, and probably jobs that we should always look for a sort of a high touch, high empathy kind of person for. And that relates to a question that's come in from one of our listeners. Al in Virginia says, I teach a graduate course on technology strategies for business to MBA students and Masters of Science students. And the question is, what kinds of career moves should these people consider after graduation? So that's a question, like, in light of this larger conversation about automation and robots and AI, what will be the safest job categories, the last things to be automated? Hal, do you want to say a little more about that, and then we can get the other panelists to jump in also?
Well, it's a big question. I would say you need to look at jobs where humans are going to have a comparative advantage, but also you have to be flexible. The most important thing that we learned at MIT, I would venture to guess, is how to learn. And in the future, you're going to have to continue to learn in order to be competitive. Now, the good thing about our preparation, our education is, I would say we're in pretty good shape in that dimension. But if you think of the model where somebody graduates from high school and then effectively stops learning, that's going to be a problem with respect to the job market.
Lynn and Mike, do you have any recommendations for safe career paths in the 21st century to stay ahead of the robots?
Michael, or either way, it's fine.
Go ahead, Lynn.
Sure. I can't agree more with what Hal said. Like, MIT really taught us well on how to learn. Anything I think I've learned in MIT, like actual content, probably a bit obsolete at the time. You know, I remember 6001 was Scheme back in the days, and now it's you know, Python, whatever. You know, obviously Scheme is nobody's using Scheme anymore, but the concept behind 6001 is stayed with me forever. And that really prepared me to learn anything new in the future. And I thought that's a incredibly good insight. And but based on my research, I've seen that, you know, at least in recent technologies, especially robotics in particular, is really about what we can tell a robot to do, what we can train them to do. You know, what kind of tasks has been displaced because of the robot. And for the robot to work, I mean, at least from my understanding, that it needs lots of data to make sure the robot can do what you intend them to do, right? But maybe perhaps, like, you know, short-term view is what kind of data that robot do not have about you, about individual. Maybe it's creativity, maybe it's something else. At least in my research, we found that the firm's ability to generate new innovation are dramatically improved because of AI. For example, IBM Watson was able to identify I think 13 new protein markers for identifying certain type of cancer. That would take researchers many years to do, including but because Watson can consume so much information at a time, they're able to link this connected concept together and then identify new areas of interest, new drugs potentially. And that is, in my view, still a type of recombination type of innovation, in the sense that you're combining existing knowledge together in order to make new ones. Okay. But for making a really brand new novel technology or new novel element is really difficult to do. Because data doesn't exist yet about these brand new technology. For example, Steve Jobs famously said that he never did any marketing research for iPhone or iPad. And because of that, it's it's really difficult. A part of that reason is because, you know, if you ask consumer what they want, and they are not going to be able to tell you what they're telling you is not going to be a brand new novel technology. So that's what I believe human intelligence and creativity comes in. That to make the leap, creating type of technology or innovation that simply did not exist, and I think that might be the value for potential value for it. And also, obviously, each new technology element, machines are so great at combining them into new things, and that's could be another way to to train, in a sense. How do we max out our existing technology to create new ones?
So be an innovator, be a computer scientist, be a programmer. Yeah, those are great answers.
It's not necessarily just programming computers. Like anything revolving creativity, right? That data simply, there's no data for creativity yet, at least the one that we can reliably capture.
Well, I hope you're right about that one. Mike, do you have any career advice for people afraid of robots?
Sure. First off is don't be afraid of the robots. Learn how to work with them. And so I would encourage those folks who are getting MBAs to have some exposure to technology, whether it's computer programming or intro to engineering or whatever, just so they're not scared of this technology. The kind of jobs that are going to persist are those that require those uniquely human abilities, empathy. They're things that, robots don't empathize with people very well, at least not yet. Being adaptive, being able to work in new situations is important. Jobs that can be made routine, like stacking boxes on a conveyor belt, those, if they haven't gone away already, they're going away. But jobs that require really good perception and understanding the world, and the ability to manipulate the world, to use our hands. Robotic hands aren't very good yet. They hardly feel anything. They're pretty clunky. They break. So if you want a research area, work on making better hands and better eyes. Those are two good ones.
Lost your signal. Yeah. Okay, you dropped out there for a second.
Okay. Over time, the frontiers of what we can and can't do are going to get pushed back, but I think it'll be slower in manipulation and in perception.
Let me interject a note of optimism here that hasn't been mentioned yet, and that's the role of demography. Now, right now, the population in the US is growing twice as fast as the labor force. The baby boomers are retiring, and after the baby boom, we had the baby bust. And if you look at projections of what the labor force is going to look like over the next 10, 20, 30 years, we are entering a period where there will be seriously tight labor markets for the next several decades. And that's pretty easy to read just looking at the demographics, the number of prime-age workers, and the current trends. Next decade, we're going to see the slowest growth in the labor force ever observed in the post-war period. So workers, human and robotic, are going to be very much in demand. So in my mind, the robot revolution is coming along just in time because we need to have serious improvements in productivity in order to keep up consumption. I mean, in order to keep up the production that's necessary for all of those non-working people. So it's a critically important issue. Those baby boomers that are retiring now expect to continue to consume. And if they want to continue to consume, there's got to be somebody that produces those goods and services that they want to consume.
So, okay.
Can I follow up on that?
Yeah, sure, Mike, go ahead.
Yeah, Hal points out a real important mismatch here. We have to make sure that the people who are entering the job market, for which there'll be a high demand, have the right skills to do those jobs. So there's not going to be a huge demand for blue-collar workers, for working in manufacturing. A lot of those jobs are done by robots already, right? The automakers use a whole ton of robots to make their cars. So the challenge is, what kind of jobs are people going to have in the future? There'll be the jobs, but will we have the workforce that can take those on? That's a great question for us in academia to try and address.
And Mike, that actually, sure, Hal, go ahead.
Let me say a word there about education. I want to bring up this idea of tasks and skills that I mentioned earlier. In some cases, the automation dumbs down certain aspects of the job. It used to be a cashier, you had to know how to make change. Well, that's irrelevant. It used to be a taxi driver, you had to know how to get around a city. Well, that's not necessary anymore either. It used to be a engineer, you need to be able to calculate all these integrals. Well, we have computers that do that for us now. That task is no longer a necessary part of the job. And so what happens is you get a broader pool of workers that can perform a given job because you've optimized the tasks, some of which are done by the machines, reading the map or making the change, and some of which are still done by humans.
We have a couple questions coming in from the audience about education and whether we're doing enough at the high school and secondary level to prepare people for the world of the future where there will be fewer low-skilled, purely manual jobs, and presumably more jobs that involve some level of programming or overseeing machines or working with machines. So you started to get into this. Could one or more of you jump in on this question of what we should be doing at the high school level and the college level to prepare?
Well, okay, nobody else is saying anything, so I'll jump right in. I think the key issue is going to be continuing education on the job training, apprenticeships, the kind of things that Michael was talking about earlier with his program. And we need better ways to deliver that training. And let me throw out one little factoid here, which I think is quite striking. Every given moment, any given day, There are 500 million how-to video views on YouTube. 500 million. And people are learning how to calculate areas of a triangle. They're learning how to tie a necktie. They're learning how to hang a screen door. They're learning how to weld. It's a whole range of tasks that go from manual tasks to cognitive tasks. Some are somewhat routine, others are not. So that's a mechanism for delivering these skills on an as-needed basis to people. And there's just wonderful educational resources out there, not just in traditional education, not just in the high school classroom setting, but in apprenticeships, online, and many other places.
But what about at the actual school level, inside elementary schools, junior highs, high schools? What should kids be taught these days? And let's just, the easy answer would be STEM, more STEM education. But does anybody want to get a little more fine-grained than that? Mike, do you have any in-classroom experience?
Sure. I have a bit, yes. So it's not quite so much what students are taught in K through 12, it's how they're taught, and are they really inspired? You know, if a student is turned on to science and math and technology, they'll do wonderfully. And if they're turned off by it, then it's forget about it. They won't be able to follow those videos that Hal referred to. So what we really need is an inspiring core of teachers who love to learn, who are not scared of technology and math and science, who can inspire that generation of kids to come along and then get to college, and we'll take it from there.
I think I echo that. I think lots of tote memorization learning is no longer necessary. I remember, at least in my, when I was in secondary education, I remember I had to memorize a lot of things, and I feel, you know, computer and robots can memorize that much faster and retrieve it with much higher accuracy than we do. And lots of the learning that, in my opinion, for secondary and junior high school level is just how to think critically, right? And you have a new problem, a new phenomena. How do you explore to solve that problem? And you can have all the tool set at your disposal, and you have internet, you have you know, any kind of resource you have, and then that's all available to you. And how do you start solving a problem that you've never seen before? Instead of closed book exams, I feel like a lot of the exam maybe potentially should be all about, you know, more project based, or, you know, because a lot of exams are still based on how well you can memorize. I think that ability is less of a it's obvious having good memories are very good, but this total memorization that is often practiced in school will be less of a
very good point. Point taken. Thanks, Lynn. We have a few minutes left, and I wanted to pivot from jobs to a related question around automation and robotics, and that's the question of security. We have at least 2 questions coming in from the audience here in Concord about hacking and cyber warfare. And as we move toward factories and offices that have way more technology than in the past, what new risks are arising with the use of internet-connected devices, robots on assembly lines, robot cars? What are the cybersecurity risks, and are people adequately trying to forecast and adjust for those?
By the way, I think you just answered one of your previous questions. You know, they say if there's one lawyer in town, he's a poor man, but if there are 2, they're both rich. The same thing applies to computer security, because if there's only white hats, then they have nothing to do, and if there's only black hats, you know, you've got to increase the demand for the white hats. So, in fact, security is a very good area to go into, I would venture to say.
Yeah, I think he definitely touched on a really important problem. Is remember a couple months ago, the internet was down because of Internet of Things getting hacked, and that faces a tremendous security concern. I think Hal is absolutely right. It's an area that absolutely needs to be worked on and researched more, and potentially a lot of more job opportunities are created in cybersecurity area.
Well, and by the way, I think it's important to understand that security is not just crypto.
You want to jump? Yeah, Mike, yeah. Could you jump in? You must have some experience trying to keep to make all of your machines hacker-proof.
Oh, it's a challenge. So, in fact, having devices that actually manipulate the world raises a whole new host of security problems. It's bad enough when a hacker can commandeer your computer, but if they can commandeer your robot and your assembly line, oh man, the kinds of mischief that can happen here are pretty serious. Here's another example. There's a recent robot called Jibo, made by Cynthia Brazil from MIT. And this is a little home robot that can monitor your kids and talk to them and read them stories at night. It's very cute and has a huge market ahead of it. But I shudder to think of what could happen if someone could commandeer your Jibo and spy on your kids, for example. That's a pretty scary situation. So there's a whole host of concerns. I think, so we'll talk about back to jobs. The job of robotic security engineer would be a very high demand, very high paying job.
All right, so that's some free career advice for all of you listeners out there. Thinking about switching careers, go into security, cybersecurity for robotics and automation. That's great. Lightning round question, and then we'll wrap up. Name the year when you think that more than half the cars on the road will be self-driving cars.
Worldwide or U.S.?
U.S. And the answer could be never.
Yeah, I think not until 2050. A lot of these technologies are much slower to diffuse than people think. I would say a minimum of 30 years from now.
Lynn or Mike, can you jump in?
Okay, I'll say in about 10 years, we'll see about half the cars being robotic. Not all of them, of course. People like to hold on to their cars a long time. But looking at the progress, and they're not going to be entirely robotic, but robotic, I'll say much, if not
Hal, can I jump back?
Yeah, you cut out there. Say it again.
Yeah, please, Hal, go ahead again.
I was just saying I thought it would be at a minimum of 30 years. So there's a disconnect there. The reason is you look at other technologies, even something like the mobile phone. The mobile phone took 30 years from the first sale to widespread use.
Good point. These things do trickle down a lot slower than people expect. Lynn, did you want to jump in with a prediction?
Oh, sure. I would say, driving as much as the human factor, regulations involved, and also morality involved, right? So I remember reading an article about, what do you do when a car hits or about to hit one person on a road or 10 people on a road? And before, you snap judgment, you do it, and there's no consequences in sense of your moral judgment. But if it's all programming software and robotics, then who's going to be responsible in making that decision? So there's it's not just technology, but a lot of regulation, a lot of ethics, lots of human judgment and regulation are involved in that issue. So I think technology will definitely be there in 10 years, but all the other issues are much harder to predict.
Yeah, great. And I hope that I'm on a rocking chair on a porch when all of this happens. Basically,
I got kicked out, so.
Yeah, I see you moved outside, Lynn.
Yeah.
Looks.
By the way, I will
location.
say that I think we would have
We'll kind of wrap up unless anyone wants to jump in.
Let me throw in one last comment on that question.
Please do, Hal.
We would have driverless cars now if it weren't for those pesky humans. Because if the entire system was driverless cars, the whole problem would be much, much easier to solve. If half of the population has driverless cars, the question you ask, that's actually much more difficult than if all of the cars were driverless.
Very good points. So it's time to wrap up. I want to thank each of our panelists today and basically say how cool I think it is that MIT and the Alumni Association are able to tap into the Institute's very wide network of experts and researchers and alumni doing things in every field. I hope that people will go back and look at the archive of past Faculty Forum Online Alumni Edition broadcasts because there's quite a variety back there. These are all on YouTube, and this session will also be posted to YouTube. Thanks again to all of our alumni panelists from the Wharton, Worcester Polytech, and Google. We didn't actually get to all of the questions, so we'll be taking the ones that weren't basically posed live today, and we'll be handing those to our panelists. So in case they have a chance to look at those questions and follow up on a one-to-one basis, we will be transmitting the rest of those. So thanks everybody for your participation. You can tweet about today's chat and future chats using the hashtag #MITBetterWorld. And you can send follow-up questions or feedback to the Alumni Association at the address alumnilearn@mit.edu. So for the MIT Alumni Association, this is Wade Roush signing off from Concord, Massachusetts. Thanks everyone for joining us.
Thanks again for joining us. For more information on future MIT Alumni Association productions, please visit our website.